My name is Kumar. I'm a professor of composite materials and advanced manufacturing in the James Watt School of Engineering. For the past decade or so, my research efforts have been focused on developing additive manufacturing enabled materials innovation, and I lead 3D printing efforts across the school. Design of materials is predominantly limited by conventional manufacturing processes. So the emergence of additive manufacturing offered a paradigm shift in this area. Here in the group, we really embrace the data-driven approaches such as artificial intelligence and machine learning to develop advanced materials. Apollo is a very big company, one of the top 100 tire manufacturers worldwide. Apollo was keen on developing some digital tools to address some of the issues associated with quality attributes of tires, cost involved in the manufacturing process, energy efficiency, and production rate. So to address these 4 key challenges of the factory, they awarded a couple of PhD projects. They wanted to really go with a university where there is strong manufacturing presence. So they thought that we would be the best fit. And I hired 2 students on that project, Akash and Vedant.
The research focus is the use of machine learning in advanced tire manufacturing processes. Last year, I visited one of the Hungary plant. Out of 100 tires, 10 are coming out to be scrap. So they cannot sold that tires because of some defects or something else. So what we want to do is we want to use machine learning on various manufacturing processes to make those processes more sustainable and energy efficient.
Essentially, I'll be researching a topic called digital twins. The digital twin essentially involves making a computer-based replica of a physical object. And what we try to do with it is to collect data from the real object and try to almost simulate it virtually in real time. And then it's used for things like maintenance or predicting the output of the machine or something maybe that's going wrong with the manufacturing and things like that. Elon Musk has said that something to the tune of most research doesn't go used. But here is a case where you're actually doing it and you will see the results, because whatever you end up coming up with, that will get used by the industry, and that instant feedback, because it's coming directly from the end user, it's really productive.
My research will have direct impact if I would able to develop a model which can be fitted in one of the manufacturing process. They can directly reduce the number of scrap.
I think in a way, this project will address the carbon footprint or the CO2 emission, economics, and energy efficiency, all the 3 things.